Good morning. I hope you guys are doing well. Sorry I can't be there. I'm at the best place, the doctor's office right now. Just kidding. No one loves the doctor's office, right? So, anyway, we're going to start with a quick review from our homework last night, and then we're going to jump into what we're going to do today. After we're going to finish this video, you guys are going to take a short test on how to find volume and surface area. Okay, today is just going to be, well, what I'm going to go over right now is just going to be volume of 7 and 8. These are just two questions from the homework that will most likely give you a small bit of trouble. All right, so the most important aspect of this is to know exactly what shape we're dealing with. All right, so if we're dealing with number 7, this is a triangular prism. Remember, prisms have matching sides on each end, and pyramids come to a point. All right, so this is a prism, and number 8 is definitely going to be a pyramid. Now it's a triangle because it has matching triangles on each side. All right, so now we have to figure out what formula we're going to use. So you go to your formula sheet, you look for a triangular prism, and you look for the volume. The volume is equal to base times height. Now, the hardest part about this is going to be distinguishing between which height we're going to use. First, we're going to solve for B. All right. Now, we know that big B is the area of the base. And the area of the base, well, we have to figure out what shape the base is. And I've highlighted the base here. And that is, yes, you're correct. It's a triangle. And the name of the shape will always be the base. Triangular prism, the base is a triangle. So we know that B equals 1/2 base times height. Now, when we're looking for big B, or the area of the base, solely look at the base. So we're looking at the triangle here. So now we need 1/2 the base. Well, the base here is 4. So that's cool. And then the height is here, which is 3. So now we have 1/2 base times height, which is 2 times 3, which would be 6. Now, the other part is to figure out what the h is. So now we're not just looking at the base, we're looking at the entire triangular prism. Well, the height of a triangular prism is the distance from one triangle to the other triangle. So if I wanted to walk from here to here, how many centimeters would that take me? 11. See this line here? Or I can use a different color. See this line here? If I could draw a straight line, that would be even better. That is 11 centimeters. All right, so we're going to color code that and make that 6 times 11, which is 66 centimeters cubed. Yes. Now, this is a square pyramid. Now, how do you know if it's a rectangle or a square? Well, you know by the numbers here. When the numbers are the same, we know it's going to be a rectangle. I'm sorry, a square, because all squares have sides that are equal. If they only gave you one number, let's say, for instance, they only gave you 10, and they said that that 10 centimeters corresponded with this side here. But because they only gave us one side, we know that all sides must be equal. Now, if, for instance, they gave us two different numbers, let's say this was 11. Then this was 11, that's 10, it's a rectangle because the sides are of different measure, right? All right, so now let's get into the work. So we know this is a square pyramid. All right, now we have to find the volume formula, which is equal to base times height divided by 3. All right, we have the same problem. We have to solve for B. So B is also the area of the base. And how do we find the area of a square? Go to the flat square, right, on your sheet. Look below it, and it should say side squared. Well, what is our side? Is it 12, 13, or 10? 10 is our side, so it's going to be 10 squared. It's going to equal our base. Our base is going to equal 100. Now you need to know the height. Well, the height is going to be the vertical height, not the slant height. Remember, the slant height is with the L, and the slant height would be 13 on this object. But the vertical height would be 12. So we would do 12 times 100, but we're dividing by 3. So because we're dividing by 3, it's a good practice to try to reduce whenever possible. So we'll go ahead and reduce here. 3 goes into 3 one time. Can 3 go in 100? It can, but not evenly. So we'll check 12. Can 3 go into 12? Of course, and that's 4. So now we just have 100 times 4 over 1, which will give us 400. And that's going to be centimeters. And because we're talking about volume, that's going to be cubed. All right. I hope that helps with the test review. Okay, so for the quiz review, you're going to take a quiz after this video. All right, so now we're going to move on to Shodor. What is Shodor? Shodor is a website we're going to use to explore the dimensions of a rectangular prism and how changing a dimension on a rectangular prism can affect the volume in the surface area. Okay, so you're going to follow along on this one. I want you guys to go to Shodor.com, and we'll come out of here. And you guys will have this on your packet. So open up your packet to this page. I believe I should have this on the bottom. What page is this? This is page... Dun, 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 dun. Excuse me, this is page 25. So if you head on to page 26, you will see this in your packet. I'll give you a chance to get there, page 26. And we're going to go through this packet. Once again, we are going to explore the relationship between changing one measurement of a rectangular prism and how that affects volume and surface area. We really want to pay attention to the volume. Really want to pay attention to the volume. So the first thing we're going to do is we're going to escape out of here, and I'll let you guys get there. And you're going to come to your Explore page. In your Explore page, you'll just type in Shodor.org. Now, this is the correct place to be. We're going to go to Activities and Lessons, okay? And then from that menu, we're going to go to Interactivate. Now we're in Interactivate, and we're going to go, you're going to see two menus here, learners and instructors. Well, today we're all learners, and we're going to tap on our activities. Give you guys a second to catch up. All right, now, once we get here, and you can just hit pause whenever you need me to slow down, just hit pause if I'm going too fast and resume, and it will be like nothing ever happened. And then you'll hit the geometry option or category, and you'll scroll down till you see surface area and volume. And yes, these are in alphabetical order. It starts off with area explorer, bar graph sorter, and you're just looking for S. Okay, P, S, okay, surface area, so SU. There we go, right there. We'll open that up. And here is what we have is a cube. This cube, or this rectangular prism, we can use, it's a cube right now because all of the measurements are 10, right? But if I change it now, it's a rectangular prism. So we're going to use this, as you guys can see down here, when I change any one of these dimensions, it calculates the volume and surface area for us. And you can change this to anything that's better for you. I know some of you guys may not like this. We can go orange, maybe in green or blue. All right, you could play around with that one, or you could go Instead of orange, you could go green, green and yellow. That's not horrible. Green and orange isn't bad. Almost looks like Christmas. All right, green and yellow, blue and yellow, black and yellow, whatever. Anyway, just pick something you like that doesn't hurt your eyes. I know everybody's eyes are sensitive. Do what is best for you, right? I'll stick with this. All right, so now what we're going to do is we're going to be changing back and forth between this and our, where is it at? Smart notebook to help fill this out. So you guys can see here that we're going to be dealing with table A right now. And with table A, we want the lengths to be 2, 2, and 4. As you can see on the Shodor website, the length is not there. It's replaced by the word depth. So we'll do 2, 2, and 4. Okay. So we'll come here. And you'll just do 2, 2, and 4. And you see that your volume is 16 and your surface area is 40. So you guys are doing this from your worksheet and your computer, but I would just write here 16, 40. Then you guys can just keep going 4, 4, 6, 2, 2, 6. All right, I'll give you guys a couple of seconds. Press pause. Go ahead and fill that out. If you are working, thank you, come back from the pause. If you are working, you would have found that you got 96, 128, and 24, and 56. Now what we're going to see is the beginning of our exploration of what happens when we change the length. And we're going to start with table B. And if we read table B, it says in table B, double the width of each prism in table A. Here's the width, and we want to double it. Well, what happens when we double something? When we double 2, what number do we get? 4. So how do we go from 2 to 4? We multiply by 2, right? So we do times 2, and we get 4 here. And we do times 2, and we get 8 here. And if we do times 2, we get 4 here as well. All right, now you guys go ahead and press pause. Go back to Shodor, and I'll do the first one with you only. And we're going to change prism A, so it's going to be 4, 2, and 4. So let's go back to Shodor, and we'll go here. And I believe we're at 4, 2, and 4. And look, our volume went from what it was to 32, and our surface area went to 64. So let's go back and plug those in, 32 and 64. So go ahead and press pause and fill in the other two. All right, now that you're back from working, if you did this correctly, you would have seen that when you do this, you will get 192, 128, 24, and 56. You can press pause or rewind or manipulate this any way you want to. Now, let's read number 3. It says, compare the volumes in the surface areas in table A and table B. What happens to the volume when one dimension is doubled? All right, so let's specifically look at the volume. So we doubled the width from 2 to 4. Then the volume for prism A went from 16 on A to 32 on A prime. Well, how does 16 get to 32? Multiply by 2. That's a good thing to do. Now, let's say if we multiply 96 by 2, does that give us 192? It does. If we multiply 24, I think I put the wrong number here. That should be 48. Yes, sir. That should be 48. I can erase that and put that in. That should definitely be 48. If we go ahead and put the right number in, 48, and this is going to be 88. And it's going to be, table B was 208. 208. and 192. All right, so let's answer the question. Okay, so when we change one volume or one measurement in a rectangular prism and it goes from 2 to 4, so it was doubled, what happens to the overall volume? Well, we can say that the volume is doubled, right? So when one dimension is doubled, the volume is doubled. Boom. All right, now let's move down here. There is really not a consistent way that the surface area is compared. I know it asks about it, but 40 to 64 is not doubling because that would be 40 times 2 is 80, 128 times 2 is not 208, and 56 times 2 is not 88. So there's really not a concrete way that surface area changes when you change one side of a rectangular prism. So we really want to look at our rectangular prisms. All right, now coming back to table C. What we're going to do for table C is we're going to read this and do as it says. The original, right? This is the original prism. This is what will happen to the prism after one dimension is doubled. And we just said when one dimension is doubled, the volume should also be doubled. So it was 54. One of the dimensions was doubled, so we should double 54, and that would give us 108 feet, centimeters cubed. All right, you guys go ahead and do number or letter E, F. Remember, we're doubling the volume. Press pause. All right, welcome back from pause. So we have 198 here, and that's going to be feet cubed. And then we have 720 here, and that's going to be millimeters cubed. All right, let's move on to page 4. Page 4, we're back. We're going to just simply copy what we had in table A here. And we're just going to copy that, and it should be 1640. This is from your table A, and I should have the same information as you. And then 96 is here, and then 128, and then 24, and then 56. Okay? All right, now we have table D. And this asks us if we start off with table A, and then we triple the length of each prism. Okay, so how do we triple? When we double, we multiply by 2. When we triple, we're going to multiply by 3. So then 4, we'll do 2 times 3, which gives us 6. 4 times 3, which gives us 12. And 2 times 3, which gives us 6. All right, now go back to Shodor and change your lengths to 2 times 6 times 4, and you'll get your volume and surface area. All right, press pause. Welcome back. All right, if you did this correctly, your volume should be 48 and 88. And we're going to have a number that's actually matching 288 and 288. That's weird, but it does happen sometimes. 72 and 120. So what happened between 16 and 48? How did we go from 16 to 48? Well, yeah, you're right. We multiply by 3. So we know that when we compare, when one of the dimensions is tripled, when one of the, you guys, my handwriting is amazing, dimensions is tripled, what happens to the overall value? The volume is also tripled. All right, scroll down, see what happens. All right, now we're going to refer to table A one more time. And in table E, we're going to take half of the length of each prism. So the length in table A for A, right, for prism A was 2. Well, what is half of 2? Well, half of 2 is 1. The length for B right, was 4. What's half of 4? 2. And the length of 2 is 1 again. So you guys go ahead and find your volume and surface area. Press pause. Welcome back. All right, now you'll see that when you went to Shodor and you change your length or your depth, right, it is depth, to 1, 2, and 4, what happened? You should get 8, 28, 48, 12, 88, and 40. All right, now, so what happens? Well, it went from 16 to 8 for A, and went from 96 to 48, and then it went from 24 to 12. The volumes were halved as well. So when one dimension is halved, the volume is also halved. So the basic overall premise is this. Whatever you do to one dimension solely on a rectangular prism affects the volume in the same manner. So if you multiply the prism by 2, the overall volume would be 2. If you multiply the length alone by 3, the volume will go up by a multiple of 3. Okay, it will also be multiplied by 3. Let's say you multiply the height of a rectangular prism by 0.75. Well, that's 3/4. The new volume would be volume, right, times 3/4. So it would be 75% of what it was. Whatever you do to one length in a rectangular prism affects the volume the same way. So a prism with a volume of 45 cubic inches has its width doubled. What is the new volume? So it was doubled, so you would do 45 times 2, and you get 90. 90 inches cubed. See if you guys can do 10 and 11. Press pause. All right, welcome back from the pause. So it was 120 millimeters, and it was doubled. So 120 times 2 would be 240. Put my equal signs in there. 240 millimeters cubed. And then finally, a square prism with a volume of 242 meters has its length cut in half. That means you're going to divide it by 2. And that's going to give us 121, correct? 121 yards cubed. All right, so there you have it. That should help you with your homework and with any questions you have. You can always refer to this video. Also, when you're doing your homework, feel free to open up Shodor. Go to the website, do the problems. It's a fun way to go over the process. I understand. Always check yourself, make sure you're right. All right, you guys. Have a great class. Do well on the test. Ask Mrs. Nuwaz if you have any more questions on volume, and I will see you guys next class. Thank you. Bye.